Molarity is the most commonly used form of expressing solution concentration, and this is what we're going to use to do calculations on solutions. Terms used in molarity is molar solution, or we will say mole per liter. They're synonyms. The formula for molarity is moles of solute over liter of solution. And we will express molarity with the capital M, which can be replaced with the units mole over liter. So capital M and mole over liter are synonymous. And this is why it's very important not to use M to abbreviate mole, because you will get confused. To calculate a molarity solution, you look at the values given in the problem and you plug it into the formula. You just figure out how many moles you have and how many liters and then plug it in. But if the molarity is given to you, the easiest way to do one of those problems is to write molarity as a conversion factor. It's telling you that if you have 1 liter of solution, you have a certain number of moles. So they're equivalent to each other, and we can write a conversion factor. Let's look and see an example. Here's an example. You have a 0.123 molar potassium permanganate solution, and it asks what volume of this contains 322 grams. The 322 grams is the given and the starting point. In any molarity problem, do not start your math with the molarity. That's going to be your conversion factor. So we have 322 grams. We can re-express 0.123 molar as 0.123 mole over 1 liter. This is our conversion factor. It's asking for volume, so I know I'm going to have to turn this over and have liter in the numerator and mole in the bottom. And I'm starting with gram. So right away I see I have to go gram to mole and then to liter. So to go from gram to mole, I remember that my formula gives me the molar mass. And so then I can get the number of moles. And then it's easy to use this molarity to go mole to liter. And I get 16.6 liters. So now I want you to try this problem. First, determine what type of problem is it, and then complete it. Okay, it says, what is the molarity? When it says, what is the molarity, you have to use the formula molarity equals number of moles over number of liters. So what do I have to start with? I have 6.73 grams, that's my solute, and 250 milliliters of my solution. Molarity is equal to mole over liter. So I'm going to have to somehow get moles and somehow get liters. To get moles, I can just use 6.73 grams and convert it to moles using molar mass. So I figure out sodium carbonate, Na2CO3, has a mass of 106 grams. And then I figure out 250 milliliters, I can just convert that to liters. Now I plug it in. 0.6063 moles over 0.25 liters, that gives me 0.254 molar. Try this problem, figure out what type of problem it is, and then proceed. It says, what volume of a 0.125 molar nitric acid solution is needed to provide 0.23 moles? Well, this is going to be my conversion factor, so I'm going to be starting with this. Molarity is given, so I use that as a conversion factor. So there's my conversion factor, and here's my starting point. Now let me think through the units. It says what volume, so I need liter. What's my unit sequence? It's going to be going mole to liter directly. So it's a one-step problem. I just flip it over, and I see moles cancel out, and I get 1.8 liters of solution. Here's another one. Notice that molarity is given. That's going to be my conversion factor. Don't start with your conversion factor. Find the other measurement. This is my starting point. Now, it says how many grams. How am I going to do this? I'm going to go milliliter to liter, liter to mole, and then mole to gram. So, milliliter to liter, liter to mole. Notice I didn't have to flip it. And then go mole to gram. Where did I get the number of grams? From the formula. So it's equal to 0.091 gram. Equivalents are something that you can often see in concentrations. Equivalents take into account charge. Basically, an equivalent is the amount of charge on one of the ions in the formula times the number of moles. Let's look at an example. If I have 1 mole of sodium ions, because the charge is 1, that's 1 equivalent. I have 1 mole of calcium ions, because the charge is 2 plus, that's 2 equivalents. What if I have 1 mole of this phosphoric acid? Well, I can either take the positive side or the negative side and look at it. It doesn't matter, because the number of positives is equal to the number of negatives. The number of positives, hydrogen would be +1, so 3 times +1, or phosphate has a charge of -3. 3 times number of moles gives me 3 equivalents per liter. Remember, this is moles per liter, so this is equivalents per liter. And you can use milli with these. You can have millimolar, and you can have milliequivalents. Remember that milli equals 1/1000th, and you use it just like you would a metric prefix as in all the other metric conversions.